Good morning, guys. Today's device is ps3 slim, and its model is 2504A. Let's check it. Stand by red light, green light, and off. No beep, no red blinking light. Let's check it. And the motherboard is now in front of me, and the good thing is that no technician has already been checked this board. So check for the status again. Yeah. So for this I have described in last of my video that whenever fault like this, that it turns off instantly without any blinking light and without any beep, then we must check first this portion of the motherboard. So let's try it. Here are some coupling resistors in this line, and in the second line there are two, and their value is around about 33 ohm or 12 ohm. It is 12 ohm, 12 ohm. Next we will check for the resistor, this package of resistors. It is also in the series of these resistors, and their values are around 50 or 60 ohm, 58, 51, 50 ohm, 50 ohm, 65, 65, 65. So this package is also fine. Now there are more 4 resistors that are giving data from this chip to the south bridge, where we must check these resistors. 59, 59, 59. So all are here fine too. And the thermal data resistors, 47 ohm, it should be 47, yes, and this should be 47, yes, and it is 99 and 99. Fine. So now I must have to check the power supplies on this motherboard. These are the power supplies. All power supplies must be in order. Some of the power supplies are for the RAM section of GPU, and the RAM section of CPU, and the main power for GPU and CPU. So let's start. If you can see the oscilloscope, here I need ground. Here I can connect a ground of my oscilloscope to this motherboard. And now step by step I will check for all of these power supplies. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 power supplies, 11. So let's start from here. There should be the oscillation on this conductor input. No oscillation. Secondly, this conductor input have the oscillation, yes. Third, the input of this, it is a 12 volt conductor. So next I will check for the GPU power supply, main power supply conductor input. It is also not responding. And this one, no. And these two conductors are for the power supply of CPU. I will check it. No. And this one, no. And this section is for the internal component power supply for this CPU. And here is I will check for this. No. It is forgive that no one supply is running. Here it is also not running. Only a single power supply is giving response, and it's if I check for its output are available 1.9 or 1.8 volt, that are important volts that goes to this DC to DC converter chip here, and I should get the output volts 1.5 volts here, but I could not get the 1.5 volts. So the problem is new. It's good that you must learn new fault here with me. And this is the clock. Oh my god, even clock is not available on this system. What the hell? Now I must go for the 12 volt that are available after pressing this start button from this power supply. They must be there here at this point. Yes, I am getting 12 volts. So power supply is working, but internal power supplies of these motherboards are not working, only the single. Okay, and here is the fuse for 12 volt. It is fine. And this fuse, oh my god, this fuse is not intact. As you can see that here 12 volts are available, but on the other point of this resistor no volts are available. It means this fuse is not intact, but it is blown up. I can make a check with this multimeter of digital multimeter reading. As you can see, if I put it here, you can see it clearly. And here is the first fuse. It is good, but this fuse is blown up, no reading. Meanwhile, I can check these fuses. There are two fuses. One is good, and the other one is this one. It is also fine. So first before we put the fuse here, I should check for the short circuit due to which this fuse blown up. We must check it. And now I will check with one probe of my digital meter on the ground and the second probe on the one point of this blown up fuse to check the shortage. And at this point there is no shortage, and on the other point even no shortage, but this fuse is blown up. There must be a wrong thing due to which this fuse blown up. We have to rectify it. So let's do it. I replace this fuse and afterward I will check. The ps3 motherboard sucks a lot of heat, but I got it. And here I will replace it with this one. Yes, and I will put this good fuse here, and it is done. Let's try it again with my workbench power supply. And here, let's see what happens. It is red standby light and I'm going to turn it on. Oh my god, the fuse has blown up again. I have heard its blown up sound. I will let you check it again. Even you can see that it is. Oh my god, it is physically blown up. You can see a hole in the center of this fuse. It is physically blown up. So first we need to check for the shortage. Here I need to confirm the gates of this dual FET and the single FET. And the single FET gate is this one. It's fine. And meanwhile, I must check for this FET, this single FET. Even its gate is fine, but let's check for the rest of its pin. Yeah, this pin is not good. So, but even there is no shortage. All pins are not showing any kind of shortage, but this pin, this logic is not good. And here is the second pin of this logic. This pin, no, it looks fine. Now it is. So this input, here I will go at the back side of this It comes from here, yes, and here is a resistance of 10 ohm or 1 ohm. It is here. So now we will determine where the power goes first, on this chip or on the back side of this chip. I should determine here, then I will decide either we should replace this chip or this FET. So here I can check that this is the power supply, and the fuse blown is here, and this power supply. And here you can see that this pin that we get, where from we get 12 volts, this pin is directly connected with the input of this fuse. Here you can see it, yes. So the output is this output is going to directly to this chip, and this chip, even it is not short but has a pin that is bad. The pin number is pin number 2. Pin number 2 is not showing a good logic, and the output is this conductor. So we must check the output conductor shortage here. It should not be short, and it is not short. So I have decided that I should pull out this chip, this FET, for the replacement. So let's do it. Yeah, I got it. And here I will check for the logic from the PWM chip of this motherboard from the back side. This logic pin number 2 was bad, now it is fine. And here one more thing that we must check for the resistance, the coupling resistance, the coupling resistance between this FET and the PWM chip. We should measure the resistance here. It is 5.3 ohm, and if I compare it with the other board, it must be 5.3 ohm, but it is 3.7 ohm, and it means this resistor is losing its value. We must replace this resistance. Yes, exact value is 3.5 ohm, but here it has changed its value. You can see that it is 5.9 ohm, around about 6 ohm. So we must replace this resistor so that this fault should not occur again. So first of all, I will put a good FET here, then I will replace the resistor, the coupling resistor from the PWM chip, and here I can get the same chip from this board, this one, and here I will put it. The key of this chip is here. This is the first pin, and here the first pin is this one. So we must put this chip back on its place in the right direction with the proper pin outs of this chip. I have got it, and I will put this chip like this, because this is the first pin here, and now I will try to solder it back on its place. That's fine. And here we must replace the resistor at the back side of this motherboard, the coupling resistor from this PWM output, this one. It should be at the value of 3.5 ohm. I need to find one from here. Maybe it's fine, 2.4 ohm. Or this one is 3.5 ohm. So I will get this resistor and replace it with the bad one. Bad one is this one. First I will get from here. I got it, and here I will replace it with this resistor. Yes, and it's fine. And now here I need again the fuse resistor for this, because it has already been blown. So yes, I got one, and here I will replace it. So now everything is perfect, and most probably we have fixed this board. So let's check it again. And here I must connect the HDD with this motherboard too, because it should work now. And on the other hand, the HDMI cable, so that we can get display on the TV. And now here it is on red standby light, and should I put the heatsink on the CPU? Yes. Now let's take a start. I'm going to turn it on. Oh no. Oh no. Fault is shown. No problem. Now I will check for the power supplies. We don't need the HDMI here. So go to the analog mode, and here is my probe of oscilloscope. Let's check the powers again. Here, first I should start from here. Yes, it is. And on the other hand, this one, yeah, it's working now. And on the CPU power supply, still here I cannot get the oscillation. This supply is dead, and it is also should be dead. Yes. And here is the CPU power supply. It is also dead. Yes. And here the main problem was with this power supply. Now it is working, and we can get the volt at this point. Yes, the 5 volts. It means some more power supplies are not good in this motherboard. Further, we will check for this CPU, GPU power supply and CPU power supply. Here we have fixed this supply. This supply is, and there must be no more fuse blown up. As you can see, it is in fine. And on the other hand, yes, it's fine. Now it is not blown up. Further check for the rest of the supplies. Here I have already checked for the fuses, and they are intact. And here is the PWM for the CPU power supply, and this is for the GPU power supply. Here I will check. No, let's check for the clock first. Should I get here clock? Yeah, the clock is maintained. It means some parts of this motherboard are now in working condition. But the main thing is that these power supplies, the GPU power is not working, and now here I can check for this 1.8 volts, and here it should be the output now 1.5 volts. Yes, it is good. So let's check for these 1, 2, 3, 4, these two power supplies sections, why they are not working. Here they should get for 12 volts, and here it should get 12 volts. Yes, no, it is not 12 volt. And there are two FETs, 1 and 2, and this one is the gate of this FET. It is not working. Here is the second one, not working. And the main output FET is not getting any clock. Here it is not getting any clock, and on the CPU side it is somehow level up the volts, but without any oscillation. Here I have replaced one chip, this PWM chip, from this board to this board, and now this section is operating. I can show you. Here you can see it in oscilloscope that these PWM's outputs, just like this, now it's working. Before that it was dead. It was totally dead. No oscillation was there. Now the oscillation is available, but at this chip now still its outputs are not available. So I need to replace this chip too. Then we will see what is the progress. So basically I think that this board was suffered with a surge voltage, a kind of surge voltage that has damaged many of its chips. So it's good for you that you can learn many of the faults, that how you can rectify them. Never throw the heat direct on the chip, but you must be careful about this and throw the heat at the sides of the chip, so that due to the stress in temperature the chip can be damaged. Let's check it again. Yeah, now it is on. So let's check for its display. Here I need to connect the HDD and the HDMI cable. And here I will put the heatsink for CPU and GPU. I'm going to turn it on. Here is the red standby light, and I'm going to turn it on. And go to the display. Yes. So guys, that was the story about this console, and I am happy that you have a chance to learn more faults, how to rectify new faults. So thank you very much and goodbye.